What's up? Welcome back. In this episode, you'll see how to solve day 15 for the advent of code. This one is called a lens library. We've got the first half of this is trying to figure out how to convert from this initialization sequence syntax into a hashed value. So each of these are little like instructions or some initialization sequence. We want to convert this or each of these comma separated things into a decimal value between 0 and 255. This is some example input. We're going to use the ASCII value and then we're going to multiply that by 17 and then find the remainder by dividing by 256. So this first part here, we have to basically go through each ASCII character and we're going to have some current value that's keeping track as we go through each of the characters. So we're going to look at R first, find what its ASCII value is in the ASCII table. And then we are going to increase the current value by R's ASCII value. Then we'll take that current value and multiply by 17. And then we will modulo that by 256. And we're going to get back some value. So in the first example here, it lets us work with this thing called hash. So let's open this up and we'll just say that we want to make some new method here called, I don't know, hash or something that's going to take some input and it will return a value. So if we print out the hash of hash, then we expect to get back the value 52. So yeah, if we run this right now, we get nil and 52. So let's go through and figure out how to follow this algorithm. So determine the ASCII code for each character. So I guess first we want to say input.chars, and then in Ruby, there is a method called ord. So if we look at this real quick, so if you have any character, if you call .ord on it, that will give you the ASCII character value for that character. So if we look at, in the example here, it says the first character of H, its ASCII code is 72. So if we look at h.ord, we get back 72. So we can use the concept of this ord thing and say .map, we can pass in ord, and that will give us all of the ASCII values. So if we run this, now we should get an array 72, 65, 83, 72. And if you go through here, we're going to see 72, 65, 83, 72. So that is the correct ASCII values for these. Now we need some like current value tracker thing. So we'll call this C and it's going to start at 0. And that's what we'll ultimately return from this method. And the first thing we want to do is increase it by this ASCII value. So maybe we'll just say .each do character, and we want to increase C by the character's value. I guess we can't use C twice, can we? Okay, so this is actually like the ASCII. So we'll increase by the ASCII value. And then what we want to do is multiply that current value by 17. C times equals 17. And then we want to multiply that value, or then we want to divide by 256 and take the remainder. So we can use this modulo operator to get the remainder. So 256, and that should give us back our value at the end here. So let's see. All right, we got 52 and 52. So that's looking pretty cool. We have a bunch of examples here, and you'll notice there's like an equal sign and a dash. Those also have ASCII values. Maybe if we just say our examples are this list here. All right. And let's see. Okay, let's switch out comes for a closing quote and a comma. And we'll insert a quote here. All right, so now we've got a bunch of examples and we can iterate over those. Examples.each do input and expected, and we're going to just print out the, just to see what we're actually getting here. So we spelled this wrong. Okay. So for RN1, we got 30, 30, 253, 253. Since all these values match, our hashing algorithm is working. And so it says, go through and sum up these results, and it should be 1320. So we'll just get result is 0, and then result plus equals that, and we should get 1320 at the end here, and we got 1320, so that's looking good. So what would the sum of the results be for our initialization sequence? So we got to grab our puzzle input, which is this giant line, and it's all one line, which is just, it's wild. Actually, I think, yeah, we could probably just put this in data equals this thing. Okay. All right, so we want to pop this maybe here. Okay, and then we're going to say examples is now data dot split on comma. And in this case, we don't actually have expected. So let's just do a new thing here. So this is going to be our like instructions or something in the initialization sequence. So now we'll say instructions dot map do instruction, and we want to get the hash value of those instructions, and we want to find the sum of those, and that's going to give us some result. We want to print out that result, and let's see what we get here. 515974. 515974. Boom. All right, awesome. So that is the solution for part 1. Oh, hey, real quick, a shameless plug, buildandlearn.dev. This is a podcast where me and my buddy Colin hang out and we talk about software development and also just things that we're building and we're learning. So if that kind of stuff interests you, head over to buildandlearn.dev. You can listen on any of the podcast players that you're used to. So yeah, let's get back into Advent of Code. Cheers. All right, let's talk about part 2. So it took me quite a while to understand the instructions for part 2. So I think it makes sense to go through and really deeply explain what's going on here. We're going to have a set of boxes, and we'll have 256 of those boxes. Each box will have an ID of the box, and then it will have some set of lenses. Our input, rather than just hashing the entire thing, we now need to like actually break out parts of the input into component pieces. Each of these instructions that are in the initialization sequence have either an equal sign or a dash. If they have an equal sign, then we're going to add something or set something in the box. If it has a minus sign, we're going to remove a lens from that box with that label. The way that I thought about this entire structure was we're going to have a hash where each of the keys in the hash is just a numeric ID. Technically, we could use an array. We'll have 256 of them from 0 to 255, and each key will point at an array of lenses. So the array of lenses might look something like this, where we'll have the label of the lens and then the focal length of the lens. So when we get an instruction like rn equals 1, this means that the label of the lens is rn and the focal length of the lens is 1. And because it's an equals, that means that we want to find which box the lens goes in or is related to based on the label. So we're going to use our hashing algorithm to find out the box ID. And then because it's an equal sign, that means that we want to either add or update the lens with this label in this box. So rn equals 1 means go through the box and find if there is a lens with a label rn, and if there is, update it to 1. If there isn't, then add a new one that has 1. Now, if we encounter an instruction that has a minus, this means we want to remove any lens with CM from any of the boxes. We're going to hash CM and find the box that goes with CM, and then we'll look through all of the lenses that are in that box and remove the one with the CM label. So given this example input here of all of these different instructions, so rn is hashed to 0, and in this case we're setting 1. So after we encounter the rn equals 1 instruction, our box 0 will look like this. After we encounter this instruction, it's a no op, since we don't have any CM lenses anywhere, so nothing happens. And then when we encounter QP hashes to 1, and because QP of 3 isn't in here yet, we add it. We keep going, we keep going. When we encounter OT equals 9, we add OT equals 9 to box 3. And then what's interesting is that later on, after we encounter OT equals 7, so before OT was 9, and now rather than adding OT7, we're going to find OT in box 3 and update it from 9 to 7. And at the end, then we're going to go through, figure out the focusing power of each lens based on how close it is to the light source, and we get some number back. We want to parse out each of these instructions, and I want to reformat it so that it's a little easier to work with. So if we come down here, we're going to comment out all of this, and let's just start from scratch here. So we're going to have our instructions are now going to be examples.map first, and we'll go through instructions.each do ins, and let's actually map this. So we want to like restructure these so that we have it split basically by that symbol. And we want to still know what symbol it was. There's a couple different ways to do this, but the way that I thought was we'll grab off the label and then an A and B, and we'll do instruction.chars. And then, yeah, then we can just say if B is equal to a minus sign, then our list is going to be, it's just going to be the label on the left. So we'll have instruction up to from 0 to -1. And then we will have the actual symbol that we want to use. So the minus sign, and then we'll have nil as our final argument. Otherwise, we're going to have the instruction is going to be, yeah, up to -2. And then in this case, A will be our equal sign and B will be our number, our focal length. So then this will be like 2 integer because we want those to be integer values. So let's see what we get back here. Print R. So if we run this, okay, so now we have it broken down, but this is incorrect. So we don't want the equal sign in there. So instruction up to, but not including that. Okay, so now we have the label. This one still also has that. So let's go up to, but not including -1. All right, so now we have our label, our instruction, and our focal length. Label, instruction, focal length. Label, instruction, focal length. So we have nil in the case of that we're removing it, but that's okay. All right, so now that we've got it in this new format, what we can do is start to build up our dictionary. Let's go through, let's call this, yeah, we'll just change that to instructions. This is an interesting pattern, right? Like instead of setting equal to, we're like flowing through and then ending up down here, and then we can keep flowing instructions. And then maybe we'll have some like dictionary, or yeah, we'll have our boxes, and that's going to be hash.new. It'll be one of these hashes that automatically initializes to an empty array because we want to have a container for each of our lenses. So now we want to go through each of our instructions, and it will have a label, it will have an instruction, and it'll have the focal length of each of these things. So we want to index into boxes with the hashed label. So we're going to use our hashing algorithm for our label. And this should give us back the list of lenses that are at that location. So what's cool about that is when we're using this default hash syntax, if it's never encountered this label, then it's going to create a new array. Otherwise, it'll give us the array that's at that key. Now what we want to do is say if the instruction is minus, then we want to remove the lens that has this label from the list of lenses. So we can do lenses.delete if, and we can pass a block. And each lens will have a label and a focal length. And if the lens's label equals label, then we'll remove it. Otherwise, the instruction will be an equal sign. So for now, we can just pop in the label and the focal length and see what we end up with for our boxes at the end. So let's just p boxes and we'll run this. Okay, so we end up with 0 points at rn1 cm2. 1 is empty, and that's fine. And then at the end, we have box 3 has OT9, AB5, PC6, and OT7. So we shouldn't have 2 lenses with the same label in this box. Instead of adding OT7 to the end here, what we want to do is update OT9. So what we need to do is say if we already have a lens with that same label, so maybe we say lens is equal to lenses.find, So if we have a lens with that label, we want to update it. Otherwise, we want to add it. So if we're updating the lens, then yeah, we're going to say update the lens to have that same focal length. And if we run this again, we get back this value, and now we have OT7 is correctly updated here. RN1 CM2 at index 0 should match what we see in the example here. So RN1 and CM2 at index 0, that looks good. And then we should see OT7, AB5, and PC6. OT7, AB5, PC6, those are at number 3. So we're looking good. So we've got boxes that have the right data in the right places. Now we want to go through the list of boxes and figure out this value here. This is going to be like the focusing power of each lens. Let's first print out like 1, 1, 1, and maybe even the product of that, just so that we can like double check the way that we're breaking this down. We want to go through boxes.each do the key, and then the value is going to be the label and the focal length of each lens. And let's print out the K plus 1, because the box number is actually the 1 indexed version of that. So we'll do K plus 1. And then we want to say times the first slot. So we want to know what index in the list of, oh, actually, this isn't label and focal length, right? This is lenses. So now we need to do lenses.each with index, actually. Do label and focal length, and then slot number. And now let's just print out the slot plus 1, and we'll print out the focal length. Okay. So now we should have the box number, the slot number, and the focal length. And then we also want like the product of those. So we need like maybe like components, I don't know, is this, and then we'll p comp and comp.inject multiplication, and let's see what we get here. All right, so 1, 1, 1, 1, 2, 2, and then we have 1, 4, 28, 40. Okay, I think this looks right. This matches what we're seeing in the example. So now what we want to do is collect these up. So we'll have some sum, and we want to do sum plus equals comp.inject, and then we'll p out the sum at the end. We should get 145. We see 145 there, so that is looking good. Now we want to do this against our instructions from data. Let's run this, and we get 265,894, 265,894. Boom, that's the answer. So that is the answer for day 15 of the Advent of Code Part 2. All right, this was pretty fun. Breaking down the instructions here, like this is like an intermediate step because we wanted to get it into a data structure that worked better for us. And I like doing that in sort of like a separate place than when we actually like iterate and do the actual instruction set. So this is like a preemptive step to format and parse out the things that we want. We could probably actually make a method here called parse that would take in some instruction and then return that value. And we can break this out into this parse method, and we can say map do instruction, parse the instruction, and then we can just run each against the result of that. And we should still get back the same answer. Okay, we're looking good. Another thing that we might want to do is, yeah, like we could clean up some of this here. We can just do sum plus equals this whole thing dot inject multiplication. Okay, same answer. That's looking good. Technically, I'm sure we could do some fancy inject thing that added all of these up, but that's probably clean enough for now. Also, our hashing algorithm here, we use the variable name C, not super, yeah, it's not very descriptive. So we could, the other thing is that like when you have a method that has a variable that's being set at the top and then the same thing is being returned at the bottom, Oftentimes there's a way to rewrite it. So maybe we can do inject, start with 0, and now we have C, and perhaps we can actually get away with this, maybe. And let's just see here. Okay, same answer. So that's cool. We could also rewrite this to use pattern matching if we wanted, but that's all right. I liked, this was like one of the things that I hadn't used a ton before is this delete if. And this is a way to delete elements from an array with a block, which is nice. And here we're destructuring into label and focal length. I don't actually know if we need to. Yeah, in fact, we don't actually need to destructure because it's implied, because each lens is a tuple of the lens and focal length. What I'm really, I don't know, I'm curious to see the new, in the Ruby 3.4, you can say it, and it will be the reference to the first block argument, which will be cool. So here we could do like it.first or something, and that would be our label. But for now, we can just do _1. There was an argument that underscore seemed like it was an optional thing. Yeah, I don't know, that's cool. What else can we do here? This syntax you might not have ever seen before. We are assigning something while in a conditional. So if we are not able to find a lens and this ends up being nil, then we end up going to the next block. So that is the same thing as saying if lens, then keep going, right? But instead of having to have it on 2 different lines, you can keep that on the same line. Yeah. All right. Fun Ruby stuff for the day. That's it for this one. Thanks so much for watching. If you're enjoying the series, please hit that subscribe button, and we'll see you in the next one. Cheers.